Mars, our planetary neighbor, has long intrigued us and invited speculation about whether life exists there. Recent successful missions like NASA's Mars rovers have yielded increasing knowledge about the red planet's geology and history. Now, a new space explorer is waiting in the wings and ready to take center stage, the Mars lander called Phoenix. Set for launch aboard a Delta II rocket, Phoenix will dig through the Martian soil and ice in the Arctic region using a robotic arm. Phoenix will use its onboard scientific instruments to analyze the samples it retrieves. By using the Deep Space Network tracking stations, scientists on Earth will be able to communicate with the spacecraft. They hope to learn more about existing water on the planet, as well as search for any signs that some form of life could exist there. The Phoenix mission should take us one step closer to the goal of someday conducting human exploration of Mars. Join us now at the Kennedy Space Center in Florida as we take an in-depth look at preparations for the launch and learn about the science of our next mission to Mars, Phoenix.
Welcome to the Phoenix Webcast. I'm your host, Tiffany Nail. Today, we're going to take you out of the studio and into the field to show you where all the action takes place in the weeks leading up to liftoff. You'll see how the rocket takes shape at the launch pad as the spacecraft undergoes its final test just a few miles away. So, let's get started. Our mission manager, Ron Mueller, is going to join me at the clean room where the Phoenix lander is being prepared for launch. But first, here's Ron to tell us a little more about the spacecraft.
The last stop on Earth for the Phoenix spacecraft is NASA's Kennedy Space Center in Florida. Built in Colorado by Lockheed Martin Space Systems, Phoenix arrived at the Space Center's shuttle landing facility aboard a U.S. Air Force C-17. From there, it was transported to a clean room at the Payload Hazardous Servicing Facility for pre-flight testing. The final checkouts include spin balance testing with and without fuel, testing the heat shield separation, verifying the launch and cruise stage systems, and conducting solar array deployment and lighting test. Workers loaded flight software and performed compatibility testing with the Deep Space Network. The parachute that will slow the spacecraft's descent through the thin Martian atmosphere was installed, and the electrical power system was put through a final performance test. The landing radar was integrated, and the entry, descent, and landing system verified. Following all the tests, the spacecraft can then be installed on the third stage before moving to the launch pad in a transportation canister. With the third stage attached to the Delta II rocket and covered with a protective fairing, Phoenix will await liftoff on its exciting journey to Mars.
I'm here now in the Payload Hazardous Servicing Facility with Ron Mueller. Thanks for joining me, Ron.
Good to be here, Tiffany.
Ron, could you explain to us your role as mission manager for Phoenix?
Sure. As mission manager, I work with the spacecraft team and the launch vehicle team here at Kennedy Space Center to ensure that the spacecraft is designed and tested to withstand the environment during launch and prepare all the steps along the way so that everything is ready for launch.
Ron, one of our viewers, Justin from Flint, asked, how do we get the lander out to the launch pad and up on top of the rocket?
The first step in moving the spacecraft out to the launch pad is to bring the third stage of the launch vehicle here to the PHSF. The spacecraft will be mounted to that third stage. That stack will be encapsulated and then transported out to the launch pad where the rest of the vehicle awaits.
Jessica from Denver wanted to know what protects Phoenix from getting damaged during the launch.
To protect the spacecraft from damage during launch, we first do a lot of analysis and testing to ensure that the spacecraft is designed to meet that environment. Additionally, there's a fairing on the launch vehicle that helps protect the spacecraft during the launch phase.
Ron, thanks for joining me outside the clean room.
You're welcome.
While final preparations are underway here on the spacecraft, the rocket that will carry it is being ready just a few miles away at Launch Pad 17A. Before Launch Manager Chuck Duvall joins me at the pad, here's our Deputy Chief Engineer Dave Solberger to tell us how the rocket is prepared for launch.
The launch vehicle that will carry the Phoenix spacecraft on the first leg of its journey to Mars is the Delta II rocket. Deltas have been carrying NASA spacecraft aloft since the 1960s, and today's Delta II has a long history of successful launches. Unlike the Space Shuttle, which is moved to the launch pad fully assembled, the Delta II is erected on the pad in stages. In a hangar at Cape Canaveral Air Force Station, workers prepare and test the first and second stages of the rocket before moving them to the launch pad. Once the first stage is hoisted into place on the pad, the 9 solid rocket boosters that will help propel the Delta II are attached. Workers then raise the second stage atop the first as the powerful vehicle takes shape. In the final days before launch, the spacecraft is attached to the upper stage booster before moving to the launch pad in a transport canister. Once the spacecraft is mounted atop the rocket and covered with its protective fairing, the Delta II awaits its thunderous liftoff and the beginning of another exciting mission to Mars.
I'm here at Launch Pad 17A with Phoenix Launch Manager Chuck Duvall. Chuck, thanks for joining us.
Thanks, Tiffany. It's a pleasure to be here.
Chuck, can you tell us what work is going on behind us here?
We're to the point of testing the launch vehicle on the pad. We've got the first and second stage mated, and we'll run through a series of electrical and mechanical checks before we do a simulated flight. We'll load the first stage with liquid oxygen, make sure that the tank system is sound and willing to take cryogenic temperatures. It's all in preparation for the spacecraft and its third stage to roll out. Once we roll them out and mate them to the launch vehicle, we'll perform an integrated test, make sure that the launch vehicle and the spacecraft are working well together, and that's all in preparation for countdown.
Chuck, I have 2 questions from our viewers. Timothy from Springfield would like to know, why does the Delta II rocket need so many boosters?
It's all about performance. How much does the spacecraft weigh and where is it going? So in the case of Phoenix, it's a fairly heavy spacecraft and it's going to Mars. So we needed a vehicle that would be able to lift off the ground with Phoenix and take it through Earth's gravitational pull and head on to Mars.
Kevin from Bowling Green would like to know, what makes the Delta II rocket the right one to carry the Phoenix spacecraft?
We look at 3 things when we're evaluating a mission. We look at cost effectiveness, we look at past performance, and capability of the launch vehicle. Can it lift the mass that we have and take it to the proper orbit? In the case of Phoenix, we looked at that, and this particular configuration of the Delta II was a perfect match for Phoenix.
Well, thanks, Chuck, for joining us, and good luck on launch day.
Thanks, Tiffany.
Phoenix Principal Investigator Peter Smith from the University of Arizona has graciously agreed to answer some additional viewer questions about the science of the mission. Here's Peter.
My name is Peter Smith. I'm the Principal Investigator of the next mission to Mars called the Phoenix mission. Phoenix is going to Mars to an Arctic region to investigate a discovery made in 2002 by the Odyssey spacecraft that the Arctic region has ice near the surface surrounding the actual exposed polar cap. In other words, it's sort of a permafrost region on Mars that was only recently discovered and whose properties are totally unknown. So Phoenix is a voyage of exploration and discovery. Putting a spacecraft down on one of the colder parts of Mars is really something that has stressed our engineering team. And so we've had to come up with a well-insulated container to hold our electronics, which only work down to certain temperatures. And then we put in heaters to keep those electronics above that temperature at all times. Now, of course, this takes some of our solar power. And as winter comes to the spacecraft, and the sun sets, it gets extremely cold, so cold that it actually freezes out the carbon dioxide atmosphere into dry ice. And you'll get a layer of dry ice that actually encases the spacecraft and no solar energy for the heaters. And so at that point, the electronics will be stressed past the point where they're guaranteed to work, and it'd be a miracle if they survive through that winter. but we may try and listen in the spring and summer of the next year just to see if it did. I suspect it won't. The robot arm is very strong. If you were to brace your legs and hold onto that arm and try and stop it from moving, it would drag you. So it's a strong arm. It may actually even move the spacecraft. So we feel very confident we can get through even very hard-packed soils. Now when we get to the very cold ice, if it's almost a pure ice, it's the hardness almost of granite. And so we've put a power tool on the end of the arm that actually acts as a rasp, and it spins and throws pieces of ice chips inside of the back of our scoop, and we can deliver those to our instruments. So we are sure that we'll get a sample of even the hardest materials. NASA developed airbags as part of the Pathfinder mission and decided to use them again for the Mars rovers. However, the spacecraft we've inherited was designed before Pathfinder was successful. Its propulsion system was designed. And so we've gone back to the landing system of the Vikings, the two Vikings, which is using thrusters. And we feel that we're very safe using thrusters. And in fact, for us to use airbags, we'd have to reduce the mass of our spacecraft. And that would mean less science and less capability. So we're very happy with thrusters. The closest we've ever been to the polar regions with a lander, a successful lander, is Viking 2. And it landed about 45 degrees north latitude. On the Earth, that would be somewhere near Chicago, I think, and very far from northern Canada or northern Greenland, which is the latitudes we're going to, using an Earth analog. Now, there was an attempt to get to the polar regions in 1999 with Mars Polar Lander. Unfortunately, it failed to land safely. And we are actually reusing some of the instruments that were on that mission. And hopefully we will have success this time. And that's really the reason for the name Phoenix. Phoenix is a long-lived bird that dies in flames and is reborn from its ashes. So it's a symbol of rebirth.
I hope you enjoyed the program. I want to thank our guests for giving us this inside look at what goes into a successful launch mission. Join us live for the Phoenix liftoff on NASA TV or on your computer at nasa.gov/Phoenix. Thanks for joining us. I'm Tiffany Nail.